All right, guys. Sorry, we're going to go over this review. This is the review for the test that you have for homework. And here we go. We're just going to get right to it. So, I'm just going to do problem number 2, 4, maybe 5, and 6. We have f of x equals 2 over x plus 3 plus 1. So I'm going to look at this, and I'm going to notice that this is in reciprocal form. And I know that because there is no exponent, or I'm sorry, there's no variable in the numerator. So this is the form that we like. This is the easy form. This is the one that we like. So when I look at this, I know that my domain, well, let's do our vertical asymptotes first. Our vertical asymptote is going to be where the denominator, we know that the denominator cannot equal 0. So we're going to take our denominator for our vertical asymptote, and we're going to say x plus 3 cannot equal 0. So we've got x equals -3 as our vertical asymptote. So when I graph that, it's going to look like a vertical line at -3, where x equals -3. Remember, when we're talking about asymptotes, we're talking about lines. So we don't need a y-coordinate. 1, 2, 3, -3. So we know that that's one boundary. For my horizontal asymptote, since this is in the form of the reciprocal, this is my horizontal asymptote right here. So y is going to equal 1. Make sure that you write x and y. You will get it wrong if you do not write x equals or y equals. So we've got y equals 1. That's going to look like this. So my domain is going to be where x is the set of all real numbers, where x does not equal -3. And my range is going to be where y is the set of all real numbers, where y does not equal 1. And so when we graph that, there's two ways to do it. You can create a table by plugging in certain numbers in for x, or you can go to your handy-dandy calculator. Now, for those of you who don't have calculators, I'll go ahead and do a table. So if I have x and y, if I were to do a table, I would say, okay, if I've got 2x plus 3 plus 1 equals y, I'm just going to kind of look at the numbers around the asymptotes. So when x is, say, 5, I'm going to have y equals 2 over 5 plus 3 plus 1. That's going to be 2 over 8 plus 1. So y would equal 1 and 2/8. Here's how you can do it if you do not have a graphing calculator. So when I go over to 5, 1, 2, 3, 4, 5, I'm going to go up to 1 and 2/8, which is just above the asymptote there, because that asymptote's at 1. So I know where that is. What if I were to say when x is, let's say, -2, which would be right here. What's that going to be? So y equals 2 times -2 plus 3 plus 1. I would get 2 over 1 plus 1, so y would equal 2 plus 1 is 3. So I can plot that. 1, 2, 3. Now what if I was I can't really do anything more, so I'm going to guess that it's going to look a little bit like that. Then what if x is -4? I know it can't be -3, so what if it's -4? What's going to happen in there? So 2 over negative 4 plus 3 plus 1. 2 divided by negative 1 plus 1. Y is going to equal 2 divided by negative 1 is negative 2 plus 1, which is negative 1. So when x is negative 4, y is negative 1. So 1, 2, 3, 4, and I go to this point right here. And then what if x was, say, negative, we'll just do one more, negative 5. So 2 divided by negative 5 plus 3 plus 1. Y would equal 2 divided by negative 2 plus 1. Y is going to equal negative 1 plus 1. Y would equal 0. So there's one of my x intercepts. And there you go. So this shows you how to, oops, I'm so sorry. There you go. This shows you how to create a table from this equation and plug in different values for x. To determine y. So then I can get a graph. If I were to use my calculator, I would just plug it in, and I would do 2 divided by, and I'm going to use parentheses so that my entire denominator stays underneath my x. So x plus 3, and then plus 1. So when I graph that, I'm going to look, and that looks pretty similar to what I have. And then I'm actually going to look at the table and just make sure that at x at negative 3 I have an error. So that tells me that the asymptote is there at x equals negative 3. All right, so number 4. Let's do question number 4. I'm going to skip number 3. You're on your own for that one. So let's talk about this one. This one is no longer in the form of the reciprocal. This is now where we have an x on top and an x on bottom. So there's a few more things that come into play here. Number 1, we need to simplify first. So that means factor. When we factor, I'm going to look to see what numbers are going to multiply to give me 6 and add to give me negative 7. So I've got x minus 6, x minus 1. If I were to multiply that out, x times x would give me x squared. Negative 1x minus 6x would give me negative 7x. Negative 6 times negative 1 would give me 6. So there's my numerator. I'd have x minus 6 in the denominator. Okay, so the minute now you see that you've got x minus 6 in the numerator and in the denominator, you're going to immediately know there's going to be a hole. We don't know where yet, but we know that there's at least going to be one, that we're going to have to deal with that when we get there. So I'm going to cancel those out, and my simplified expression is just y equals x minus 1. Here is my simplified expression. So when I'm looking at that, I'm going to say, okay, what is my x-intercept? And as we talked about, this is going to be a point. So I need an xy coordinate. I know the y is going to be 0 because anytime anything crosses the x-axis, y is 0. So x minus 1, we're going to set the numerator. This is where you set your numerator, equal to 0. X minus 1 is the numerator. I do not have a denominator, or the denominator is actually 1. But in this case, I'm going to set this equal to 0 because that's what I would do. And I'm going to get x equals 1. So I've got 1 is my x-intercept. So I can go ahead and plot that. 1, 0. Now, if you happen to notice the fact that this is going to be a line, you could probably graph that this would be your y-intercept and you've got a slope of 1. That's way back in Algebra 1. But let's just go ahead and go on. Our vertical asymptote is where your denominator is equal to 0. And in this situation, I do not have a denominator, so I'm not going to have a vertical asymptote. And of course, again, if you notice that this is going to be a line, you would not have a vertical asymptote, which means you're not going to have a restriction on your x values with regard to an asymptote. What about my horizontal asymptote? Well, I'm now kind of dealing with where the numerator is bigger than the denominator because I've got a degree of 1 over a degree of 0. So my horizontal asymptote is going to be none because this is where it's bigger on top. So there would be none. Because we've got basically x minus 1 over 1. Alright. So this is going to be none as well. Now let's deal with our hole. So I know there's going to be a hole where this would equal 0, because if there was a 0, then that would create that to be undefined, even though they cancel each other out. So there is a hole where x equals 6. And since we're talking about a point, we need to figure out what the y-coordinate is when x equals 6. So I'm going to take this simplified equation and plug in 6 for my x. So I'm going to take y equals x minus 1, and if x equals 6, I'm going to say y equals 6 minus 1. Y would equal 5. So that hole is going to be at 6, 5. I can go ahead and graph that at 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Here is a hole. Then I'm going to look for my domain. Well, my domain is going to be a set of all real numbers. There's no restriction for my vertical asymptote, but the only restriction is that x cannot be 6 because it's in this hole. Same with my range. There's no horizontal asymptote, so there's no restriction there, but there is a restriction at 5. So we've got domain and range is that. Now, how would we graph this? Well, luckily, since I teach Algebra 1, we do it every day. And basically, I've got it in y equals mx plus b form, where y equals 1x plus, minus 1. I didn't mean to put plus, minus 1. So I can go to my y-intercept at -1, plot that, then use my slope of 1, up 1 over 1, up 1 over 1, up 1 over 1, and connect my points. I just want to make sure that that hole is not included. So there you go. And there is your graph of that. And just to double check it, I'm going to go ahead and plug it in the calculator and see what that looks like. So I'm going to go to y equals, and I'm going to go ahead and plug in this whole original, this whole original equation. So I'm going to type in parentheses, I'm putting my numerator all in parentheses, x squared minus 7x plus 6, and a parentheses divided by parentheses x minus 6, and the parentheses graph. And lo and behold, it looks, now the one thing it doesn't show is the whole. So I'm actually going to go to my table and look and see what is the value of x when it is 6. And sure enough, it says error, meaning that there is no value associated with x equals 6. There's no value. So I got that right. So I can say check, I know I got that right. Flipping it over. Let's do number 5. And so the first thing is to simplify. All right, and so the numerator is going to be x minus 4. I take the square root of x squared, the square root of 16. X plus 4, the square root of 16 is 4. Then what two numbers are going to multiply to give me 24 and add to give me 10, and that's going to be x plus 6, x plus 4. And lo and behold, I'm going to have a whole, so I know I'm going to have a whole. So let's get started. So I'm going to take my simplified equation of y equals x minus 4, x plus 6, and I'm going to try and find my x-intercept. That is where my numerator equals 0. So when x minus 4 equals 0, x equals 4. I know that when x is 4, y is going to be 0. So I can go ahead and plot that. 1, 2, 3, 4. Then my vertical asymptote is where my denominator equals 0. So I'm going to take my x plus 6 equal to 0. That's going to give me x equals negative 6. This is a line. So I need x equals negative 6, and when I graph it, I'm going to graph it as a line. My friend Vux tells me it's going to be a vertical line, plus it's a vertical asymptote. So I know it's going to be vertical at negative 6. 1, 2, 3, 4, 5, 6. Dun, 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 dun. So I know that there's going to be that restriction on my domain at negative 6. I also know there's going to be a restriction on my domain at the whole 2. My vertical asymptote, or my horizontal asymptote. So now I need to look at the very biggest exponent on my numerator and my denominator. And I look at them both and I see that the numerator, the biggest exponent in my numerator is a 2. I look at my denominator and I see that the biggest exponent in my denominator is also a 2. So since they are both 2's, we are dealing with eats DC. Exponents are the same. So we're going to divide the coefficients. The coefficients of x squared is 1. So we're going to have y equals the coefficient of x squared, and the coefficient of x squared in the denominator is also 1. So we're going to end up with a asymptote of y equals 1. So when I graph that, it's going to look like this. Alright, so now it's kind of taking shape. Y equals 1. So now where is this hole going to be? Let's figure it out. So we're going to go x plus 4 over x plus 4. We know that the hole is where x plus 4 equals 0. We're looking for a point, so we need an x, y value. So x is going to equal negative 4. Now, since I know that the x value equals -4, what does the y value equal? Well, let me find out, because I'm going to look at my equation and say, if x were -4, what would y be? Well, let's work it out. Y equals -4 minus 4 divided by -4 plus 6. Y is going to equal -8 divided by 2, so y would equal -4 as well. So my xy point is going to be -4, -4. So I'm going to go ahead and plot that. 1, 2, 3, 4, 1, 2, 3, 4. So now we have essentially 2 points on this side of the graph. And so I can go ahead and kind of connect those up. My domain is going to be x, where x is the set of all real numbers, where x cannot equal -6, but it also cannot equal -4, because there is that hole right there. And y is going to be the set of all real numbers where y cannot equal 1, and it also cannot equal -4, because there is a hole where y is -4. So it looks like we kind of have this side of the graph, but we don't really have this side of the graph. Now again, you can start plugging in numbers to see what that would be. Create a table, maybe plug in -7, -8, -9, -10. But I'm just going to plug it in my calculator and just see what kind of problem or what I come up with. And I'm going to put parentheses x squared minus 16 and a parentheses divided by parentheses x squared. I'm going to use this plus 10x plus 24 and a parentheses and graph that. Alright, so here's your graph. So just to get a good indication, I noticed that this is about right, but I'm going to look at my table, number 1, to look to see if I have asymptotes where they're supposed to be. And here at x is -4, I have an error, which is perfect because that matches the hole. When x is -4, I have a hole, so that's what I want. When x is -6, there's an error, and that's perfect because that matches my vertical asymptote. And so then I'm going to go ahead and say, all right, when x is -7, y is 11. So that would be actually 1 just right off the graph. Then if I had x is -8, go 1 over to the left, y is 6. So 1, 2, 3, 4, 5, 6. And then when x is 11, which is 1 off the graph, y is 3. So 1, 2, 3. So, oops, I totally missed that. So there you go. That's about right. And then I'm going to go back and look at my graph, and they look very similar. Okay, so we're going to stop the video here, and I'll do another video for problem number 6.